Hello everyone, my name is Thủy, and today I will tell you about my lesson plan of teaching total internal reflection phenomenon by using experiments. So, firstly, we need to know two new concepts. The first is the definition of total internal reflection. Total internal reflection is the phenomenon that occurs at the boundary between two mediums, such as if the incident angle in the first medium is greater than the critical angle, then all the light is reflected back into that medium. And second is the conditions for total internal reflection phenomenon to occur are: first, the light must be traveling from a more dense medium into a less dense medium, and the second, the angle of incidence must be greater than the critical angle, where critical angle can be calculated. C equals arcsine of n2 divided n1, where n is refractive index of two mediums. Okay, and secondly about the how to eclipse problem. Last lesson, students knew about the law of reflection and reflection phenomenon. So I will revise my students by asking them what happens to the light if I beam the light from the glass to the air. And let's compare the incident angle and refracted angle. And our problem is, when I increase the angle of incidence, what happens to the refracted angle? And to solve this problem, students need to answer two questions. The first is, how does the phenomenon look like? And the second is, in which conditions the phenomenon happens. And we can approach this problem by theoretically. According to the law of reflection, in this situation, when the light goes through two mediums, the rays are bended. And when the incident angle is increased, the refracted ray is seen to be farther away from the normal until the angle of refraction R becomes 90 degrees, and the refracted ray now travels along the plane surface of the glass block, and the angle of incidence in the glass block at which the angle of refraction in air is 90 degrees is known as the critical angle C. And according to Snell's law, the critical angle C can be calculated sin C equals n2 divided n1. And if the angle of incidence is greater than the critical angle, the light ray will be 100% reflected back into the glass box, and no light gets refracted through the glass to air boundary. Okay, and this is the theoretical approach. How about experiments? So I will let my students some minutes to design an experiment to answer the question before. And it's so easy because it's quite similarly to the reflection experiment. And after that, I will introduce the total internal reflection experiment. About the apparatus, it concludes paper laminate lamp, semicircular slabs, and some notice before doing experiment. First, we do experiment in dark room and to limit out the light, and it helps us to observe clearly the experiment phenomenon. And the second, we put the paper laminate and semicircular slabs are concentric, and it's convenient for measuring the incident and refracted angle. Okay, and to be more understand about the experiment, we will watch this video, and this video will follow some produce that I saw in the screen. Let's watch this video. Experiment setup includes paper laminate, lamp, and semicircular. Total internal reflection will occur when the angle of incidence is greater than the critical angle. When the angle of incidence is less than the critical angle, when the angle of incidence is greater than critical angle, no light is refracted, and all of light is external refracted, creating the total internal reflection. And this is the total internal reflection. Okay, and this is the conclusion of this lesson. After this lesson, we need to remember two concepts. The first is the definition of total internal reflection. Total internal reflection is the phenomenon that occurs at the boundary between two mediums, such as if the incident angle in the first medium is greater than the critical angle, then all of the light is reflected back into that medium. And the second thing we need to remember is the condition for total internal reflection. The first, the light must be traveling from a more dense medium into a less dense medium. And the second is the angle of incidence must be greater than the critical angle. And we can calculate critical angle C equal arc of n2 divided n1. And to be more excited about this lesson, let's go to the elaboration part. And in the part of experiment, we observe the rainbow, and I will ask students go home and finding the answer for question why we observe the rainbow in this experiment. And this is all about my presentation. Thank you for listening. If you have any comments or questions, please send me at my address. Thank you for listening. Goodbye.